Welcome to the Explainer. Today, we're taking a really complex data problem and turning it into something a little more fun, a head-to-head competition. We are going to pit several different AI models against each other to see which one comes out on top at predicting the earliest signs of Alzheimer's disease. So, let's dive right in.
So this is the big question, right? Can an algorithm really look at a bunch of clinical data and see the subtle patterns that even a trained human eye might miss? Well, to even think about answering that, we have to start with the most important ingredient of all, the data itself.
And here it is. This is our playing field for today's competition. This data comes from a project called OASIS, and it's fantastic. It tracks over 150 people over time, giving us things like their age and education, but also these really crucial clinical scores, like the MMSE, that's the Mini Mental State Exam, and the CDR, the Clinical Dementia Rating.
Okay, but you can't just take this raw data and throw it at an AI hoping for magic to happen. It's usually pretty messy. Think of it like a puzzle. All the pieces are there, but we need to assemble them correctly before the competition can even start.
So every good competition needs a finish line. And here's ours. We want to train our AI competitors to look at a patient's gender, age, education, and some brain measurements and predict one simple thing. Does this person have a clinical dementia rating greater than 0? A score above 0 means there are signs of dementia. It's a straight-up yes or no question.
All right, let's get into the prep phase. Before any of our models can even start competing, we have to clean up the field and make sure the rules are fair for everyone. Honestly, this is one of the most important parts of any data science project.
We're going to tackle this in 3 key steps. First, we have to fill in any blank spots in the data. Second, we're going to look for any really strange or extreme values that could kind of throw things off. And third, we'll put all the numbers on the same scale so no single measurement gets an unfair advantage.
Step 1 seems simple, but it's absolutely vital. A quick check shows us that a couple of columns, socioeconomic status and the MMSE score, have some missing entries. Now, instead of just deleting those records, we do something smarter. We fill in the blanks with the median, that's the middle value, from all the other data. This way, our dataset stays complete without messing up the results. Next up, we go hunting for outliers. Now, what are those? They're data points that are just wildly different from everything else. Think an unusually low cognitive score for someone, or a really long delay between MRI scans. We have to spot these because they can act like a speed bump on the racetrack, unfairly tripping up a model's performance.
And finally, we standardize the data. Okay, imagine you're comparing a person's age, which might be a number like 80, with a brain volume measurement that's a tiny decimal number. And AI might just assume the bigger number is way more important. So standardization puts all our numbers on a similar scale, creating that perfectly level playing field for our competition.
All right, the data's prepped, it's cleaned, and it is ready to go. The stadium is officially ready. So now it's time to meet the actual contenders in today's machine learning showdown.
We've got 5 different competitors lined up for today. First, there's the simple decision tree. Then we have Random Forest, which is basically a whole team of decision trees. We've also got the support vector machine, or SVM, which tries to find the clearest line between groups. Then there's XGBoost, a real powerhouse model. And finally, the voting classifier, which is basically a team-up of the best of the others. Each one has a totally unique strategy to win this thing.
So let's get to know our first competitor a little better. The decision tree is the most straightforward of the bunch. It works just like a flowchart, asking a series of yes or no questions. For example, it might ask, is the patient's age over 75? If yes, it goes down one path. Then it might ask, is their cognitive score below 24? It just keeps following these branches until it reaches a final prediction, demented or non-demented.
The stage is set. The data is ready. It is time to let these models compete. We're going to score our 5 models on 4 key metrics to find our ultimate champion predictor. Let the showdown begin.
Round 1 is all about pure accuracy. This is the most basic metric. Out of all the predictions, what percentage did the model just get right? And as you can see, right out of the gate, Random Forest jumps into an early lead, correctly predicting the outcome more than 85% of the time. That's a really strong start for the forest of trees.
For our second round, we're looking at precision. This one's super important. It asks, when the model predicts that someone has dementia, how often is it actually correct? This is all about avoiding false alarms. And would you look at that, once again, Random Forest takes the top spot.
Its positive predictions are the most trustworthy in the entire group. Round 3 is recall, which is kind of the flip side of precision. This measures how good a model is at finding all the patients who actually have dementia. In medicine, this is critical. You do not want to miss a diagnosis. And here, the race gets a lot tighter, but Random Forest is still a top performer, successfully catching almost 80% of all the true dementia cases.
And that brings us to our final round, the F1 score. See, you need a balance, right? You can't be missing cases, that's recall, but you also can't be raising a bunch of false alarms, that's precision. The F1 score brilliantly combines them into one single number. It's the ultimate test of overall performance. And with the highest score here, Random Forest is officially crowned our champion. It has the best balance of being trustworthy and thorough.
So after 4 pretty intense rounds, Random Forest is our undisputed champion. But, winning is one thing. Let's take a look at the tail of the tape to understand exactly how it dominated the competition, especially when you compare it to our simplest model, the decision tree.
Okay, let's look at the mistakes they made, side by side. These are called confusion matrices, but think of them as scorecards. On the left, the single decision tree made 87 total errors. It incorrectly flagged 47 healthy patients and completely missed 40 patients who did have dementia. Now look at the Random Forest on the right. By combining hundreds of trees, it slashed the total number of errors all the way down to 54. I mean, that is a huge improvement in diagnostic accuracy.
And for the final verdict, we have this graph, the ROC curve. Just think of this as the ultimate test of a model's diagnostic ability. The closer a model's line gets to that top left corner, the better it is at telling the two groups apart. And that score, called the AUC, confirms everything. Random Forest, that orange line, has the highest score at 0.929, making it an excellent classifier, hands down.
So this really explains why our champion won. The power of Random Forest is that it's what we call an ensemble method. Instead of relying on just one decision tree, which might have its own blind spots, it builds hundreds of slightly different trees and then has them all vote on the final answer. It's the wisdom of the crowd. That collective wisdom cancels out individual mistakes, making it way more accurate than a single tree could ever be on its own.
And all of this brings us to the most important takeaway. We've just seen that an algorithm can predict dementia with some pretty impressive accuracy, just from basic clinical data. So the real question isn't about the technology anymore, it's about us. What do we do with this power? How can tools like this change the future of diagnosis, of treatment, and of care for patients and their families? That's the conversation we really need to be having next.